Very good afternoon, students.
Good afternoon,
Good
sir.
afternoon.
Good afternoon. Without wasting any time, let us start with the discussion. Right.
Yes, sir.
So last class we have been discussing about Juma's method. Right. This was a last example which we
Yes.
have discussed. Yes. So this was a formula. So the percentage of nitrogen is equals to 28 by 22,400 into volume of nitrogen at STP in ml divided by weight of organic component 200. If they have performed the reaction at any other condition, then you have to find out the volume of nitrogen using your ideal gas equation. PV is equals to nRT, that is P1 V1 by T1 is equals to P2 V2 by T2. Substitute, get the volume of nitrogen at STP, solve it, you will be getting the right answer. So in the Dumas method, whatever the nitrogen you have, that is actually converted to the free nitrogen gas, N2 gas. Whatever the nitrogen we have in the organic compound, that is converted to N2 gas. Right, students? Let us start with the discussion. The next method is Jaldal's method. Yes or no? Jaldal's method is, in this method, nitrogen in the organic compound is converted to ammonia. Whatever the nitrogen we have, that is converted to ammonia, that is through ammonium sulfate formation. A known mass of organic compound, that is whatever the organic compound you are taking, that mass of that organic compound should be known to you. A known mass of organic compound containing nitrogen is heated with a concentrated sulfuric acid in the presence of K2SO4 and CuSO4. Then nitrogen in the compound is converted to ammonium sulfate. K2SO4 increases boiling point of H2SO4 and CuSO4 acts as catalyst. So what is actually happening in this reaction? That we want to know. So organic compound, whatever we have, students, that is treated with a sulfuric acid, and the nitrogen present in the organic compound is converting into ammonium sulfate. And the resulting solution is distilled with a excess of NaOH, so that the ammonium sulfate and NaOH is going to be added. Whatever the acid we have, that will be reacting with NaOH, and we left out with some amount of acid. So this NaOH, upon reacting with ammonium sulfate, it forms ammonia. It forms ammonia. Understand this point carefully. We have acid. Acid is added to organic compound, and we got ammonium sulfate. Ammonium sulfate, and this ammonium sulfate is converted to ammonia in the presence of NaOH. That means with the help of some acids, we produce ammonia. Let us say some 10 ml of acid is taken. Out of this 10 ml of acid, some 5 ml has been lost in this total conversion because we have added NaOH. NaOH also reacts with acid. So 5 ml is lost, let us say. So what is the acid left out? How much acid will be left out? 5 more ml. This 5 more ml will be reacting with ammonia. The titration of ammonia with the volume of acid left out, that will try to estimate the percentage of nitrogen. Is that point clear to everyone or not? Simple logic is, we have some acid. That acid has been treated with organic compound. The organic compound containing nitrogen has been converted to ammonium sulfate. That ammonium sulfate is again converted to ammonia in the presence of NaOH. The ammonia, whatever it is there, which is a base, that will react with the excess of acid left out, or the volume of acid left out. I am saying left out means what? Some amount of acid has been already reacted with the NaOH. So saying like this is very simple. Yeah, we have taken volume V, some amount is reacted with NaOH, and remaining volume has been reacting with ammonia. So using that, we are calculating the percentage of nitrogen. But how to get the real formula? That is going to be the mathematical analysis, quantitative analysis. Let us look at that part. Let us take, let us take, or let us consider capital V ml of H2SO4 of molarity capital M. I am considering V ml of the acid, that is H2SO4 of molarity capital M, and V1 ml of NaOH of same molarity. of molarity M. I have considered how much ml of acid, students? V ml of H2SO4 of molarity M, and we are trying to add V1 ml of NaOH of molarity M. How much ml of molarity M, like V1 ml of NaOH of molarity M reacts with how many ml of H2SO4 of same molarity M? V1 ml of NaOH will be reacting with how many ml of NaOH? V1 ml of NaOH will be reacting with how many ml of H2SO4? H2SO4 gives one molecule of H2SO4 gives 2 H plus ions, whereas one molecule of NaOH gives only one OH minus. So if V1 ml of NaOH we have taken, how much ml of H2SO4 is required? V1 ml of molarity M, V1 ml of molarity M NaOH requires V1 by 2 ml or not? Because what is concentration? Concentration is number of moles by volume. What is number of moles? Concentration into volume. Concentration of NaOH M, volume is V1. So how many moles of NaOH we have taken? Write down these equations. Okay. H2SO4 gives 2 H plus ions and NaOH gives only one OH minus ion. Concentration is equals to number of moles by volume, or number of moles is equals to concentration into volume. Number of moles is equals to concentration into volume. So I can say V1 into M moles of NaOH, V1 into M moles of NaOH is equivalent to V1 into M moles of OH minus ion, moles of OH minus ions. V1 into M, because number of moles is equal to concentration to volume, right? V1 into M moles are millimoles, because volume if you have taken in ml, you can say millimoles. V1 into M millimoles of NaOH is equivalent to V1 into M millimoles of OH minus ions. And V1 by 2 ml of molarity M of H2SO4 is equivalent to V1 by 2 into molarity M. How many moles you are getting? V1 by 2 into molarity M moles of H2SO4. Therefore, number of moles of H plus. Therefore, number of moles of H plus is equal to 2 into V1 by 2 into M, that is V1 into M moles. That means what I can say now, students, is if I take a V1 ml of molarity M of NaOH, I require V1 by 2 ml of H2SO4 of same molarity for the neutralization. That is, ultimately we can say V1 by 2 ml of M NaOH, molarity M NaOH, is equivalent to V1 ml of molarity M NaOH is equivalent to V1 by 2 ml of molarity M H2SO4. Therefore, volume of acid left out, how much? Left out. What is the initial volume of H2SO4? Initial volume of H2SO4 is VML, and we have added V1 ml of molarity M NaOH. V1 ml of molarity M NaOH neutralized V1 by 2 ml of molarity M H2SO4. So what is the volume of acid left out?
V1 by 2.
V minus V1 by 2 or not? V is the total volume of acid taken. V1 by 2 acid, V1 by 2 ml of acid has been reacted with NaOH. So how much acid is left out? Initial volume VML minus V1 by 2, whatever has been reacted with NaOH. Is that clear, Vashita?
Yes, sir.
Yes. So V1 by 2 ml of acid neutralized with V1 ml of NaOH. So what is the volume of acid left out is V minus V1 by 2. How much acid is left out? V minus V1 by 2. And now this much acid will be equivalent to how many ml of NH3? NH3 also has a n factor of 1. H2S4 has n factor of 2. Therefore, also V minus V1 by 2 ml of a molarity M H2SO4 is equivalent to react this much amount of acid. This is acid left out. This has been reacting with ammonia. So this will be reacting with how many ml of ammonia? Can anyone say? V minus, like if I say V1 ml of NaOH is equal to V1 by 2 ml of H2S4, that means NaOH has an n factor of 1, H2S4 has an n factor of 2. Or I can also say V1 by 2 ml of H2S4 is equivalent to V1 ml of NaOH. That means half of V1 of H2S4 is reacting with of double that of volume of NaOH of a 1 n factor. Similarly, V minus V1 by 2 ml of molarity of H2S4 is equivalent to 2 into V minus V1 by 2 ml of ammonia of molarity M. Can I write like this or not?
Yes.
Because H2S4 is producing 2 H plus ion, whereas ammonia will react with only 1 H plus ion. So I require 2 times that of V minus V1 by 2 ml of ammonia of molarity M. So this is the volume of ammonia which is going to be reacting with the amount of acid left out. So let us continue with the same discussion. Okay, just a second. Yes. So 2 into V minus V1 by 2 ml of NH3 is reacting or is required to react with acid left out. So from this, what you can say, 2 into V minus V1 by 2 ml of ammonia is required to react with acid left out. From this, what we can say? From this, can I continue the discussion? Like if I take 1000 ml of 17 gram of NH3, it will have a molarity of 1 molar, which contain out of 17 gram, how many gram will be the weight of nitrogen, which contain 14 gram of nitrogen. So what is the formula? Concentration is equals to number of moles by volume. Number of moles is equal to concentration into volume. What is the concentration? 1000 ml. If you take, molarity is equals to weight of solute divided by molar mass of solute into volume of solution in ml divided by into 1000 by volume of solution in ml, right? Into 1000 divided by volume of solution in ml. Right? Here I have taken volume of solution as 1000 and weight I have how much taken? 17 gram. Molecular mass of 17 gets cancelled, 1000 gets cancelled. So I'll be having molarity 1. So concentration is equal to number of moles by volume. Number of moles is equal to concentration into volume. What is the concentration? So 1 molar is a concentration, volume is 1000 ml. 1 molar into 1000 ml is equivalent to how many grams of nitrogen? 14 grams of nitrogen. How much molarity we have taken for ammonia? Molarity M. What is the volume of ammonia? 2 into V minus V1 by 2 ml. Yes or no? 1 molarity into 1000 ml is equivalent to 14 grams of nitrogen. Molarity M into V, 2 times that of V minus V1 by 2 ml of ammonia is equivalent to how many grams of nitrogen? Cross multiplication. 14 into molarity M into 2 into V minus V1 by 2. 14 into molarity M into 2 into V minus V1 by 2 whole divided by 1000. These many grams of nitrogen. Yes or no? These many grams of nitrogen. So what is the percentage of nitrogen now? Therefore, percentage of nitrogen is equals to weight of nitrogen by weight of organic compound into 100. What is the weight of nitrogen? Weight of nitrogen is this one. 14 into molarity M into 2 into V minus V1 by 2 whole divided by 1000 whole divided by weight of organic compound into 100. If you try to solve this, how much you'll get? 2 into molarity can I write as normality of the acid? M is what? M is nothing but molarity of the acid. M is nothing but VML of H2SO of molarity M we have considered. M is the molarity of acid. 2 into molarity is nothing but normality of acid. 14 into 100, 1400 divided by 1000 is 1.4. 1.4 into normality of acid into V minus V1 by 2 is volume of acid left out, volume of acid left, and in ml divided by weight of organic compound. This is the formula. Everyone got the formula or not? So here we have just derived the formula so that you can understand how we are actually doing the titration and all, like which equivalents are actually equivalent to which type of other species. So 1.4 into normality of the acid, 1.4 into normality of acid, because 2 into molarity is nothing but normality, into volume of acid in ml. Volume of acid neutralized with ammonia in ml divided by weight of organic compound. So this is the formula to actually calculate the percentage of nitrogen. So let us look at the formula. Ammonia evolved is absorbed in known but excess volume of standard HCl or H2S4. Percentage of nitrogen is given by this formula. Percentage of nitrogen is equals to 1.4 into V into N divided by weight of organic compound. The same formula we got or not? 1.4 into V acid reacted with the ammonia into normality of acid divided by weight of organic compound. Percentage of nitrogen is equal to 1.4 into V into N divided by weight of organic compound, where V is the volume of acid in ml neutralized by ammonia. Yes or no? How much acid is neutralized by ammonia? That means how much acid is left out, that is neutralized by ammonia. N is the normality of acid. Everyone got this formula or not, students? We have to apply this formula only. Don't worry with the derivation part. We have just derived it in class so that you can understand how this formula came. So percentage of nitrogen is equals to 1.4 into volume of acid reacted or neutralized with ammonia into N is normality of acid divided by weight of organic compound. So this method is simpler and more convenient. And it is mainly used to find percentage of nitrogen present in foodstuffs, soils, fertilizers, and various agricultural products. Right? So, and under what conditions this is not useful? Like this method is not going to be applicable whenever the nitrogen present in the organic compound is not taken out in the form of ammonium sulfate or ammonia. So I can say azo compounds, nitroso compounds, nitrogen involved in the ring, NO2, all these are not going to be coming out as ammonia. So for all those species, we cannot apply this Gellal's method. Okay, this method is not applicable to nitro, nitroso, azo, azoxy, and nitrogen present in the ring like pyridine and quinoline. Because nitrogen present in this compound is not quantitatively converted into ammonium sulfate. Is that clear? There are a lot of compounds where you cannot apply Gellal's method, like nitro, nitroso, azoxy, nitrogen present in the ring. For all these, you cannot apply this particular method. Simple reason, students. What was the reason? The reason is the nitrogen in the organic compound cannot come out of that as ammonia. Is that clear to everyone or not?
Yes, sir.
Yes, sir.
Yes, right. Try to solve this question. In Gellal's estimation of nitrogen, the ammonia evolved from 0.5 grams of organic compound, neutralized 10 ml of 1 molar H2S4. Calculate the percentage of nitrogen in the compound. What is the formula? Percentage of nitrogen is equals to 1.4 into volume of acid neutralized with ammonia into normality of that acid divided by weight of organic compound. 0.5 grams of organic compound weight is given, 1.4 is a constant. You find out volume of acid reacted with ammonia and normality. Do the calculation, all of you. Do the calculation and try to find out volume of acid reacted with ammonia. percentage of nitrogen is equals to 1.4 into volume of acid divided by weight of organic component to normality. So what is the volume of acid and what is the normality? 1.4 into volume of acid is how much? 10 ml of 1 molar H2S4, 0.5 gram of organic compound neutralized, 10 ml of 1 molar H2S4 means, can I say 10 ml is the volume of acid neutralized with ammonia and 1 molar H2S4 is 1 into 2 divided by weight of organic compound 0.5. Yes or no? Volume is 10, normality is molarity into n factor. So 1.4 into 10 into 1.
0.56.
How much is it?
0.56.
How come it will be 0.56? Check it out once.
P6.
Because 56, right? Because 1.4 by 0.5 we have.
Sorry.
Okay, 56%. So same thing we can do in the formula or derivation manner also. We'll get 56%. We have the formula derived as well. Simply substitute, get the answer. And then the estimation of halogen in the same technique, whatever the halogens we have, they are going to be converted to respective silver halides. And you have the same formula for all types of halogens. Percentage of any halogen is equals to atomic weight of halogen. We have the generalized formula. Atomic weight of halogen divided by molecular weight of silver halide into weight of silver halide formed divided by weight of organic component to 100. Like how it is obtained means whatever the halogen we have, that is converted into silver halide. This is a technique. A weighed amount of organic compound is heated with a fuming nitric acid. A weighed amount of organic compound is heated with a fuming nitric acid in the presence of silver nitrate contained in a hard glass tube called as Carrier's tube. Carbon and hydrogen present in the compound is converted to CO2 and H2O. Halogen present in the compound is converted to silver halide. Whatever the halogen we have, that present in the organic compound, is converted to respective silver halide AgX. So therefore, percentage of particular halogen, from this you can write down atomic weight of halogen divided by molecular weight of silver halide into weight of silver halide obtained divided by weight of organic component to 100. Atomic weight of X divided by molecular weight of AgX into atomic weight of halogen divided by molecular weight of AgX into weight of AgX formed divided by weight of organic compound into 100. For any types of silver halide, for example, if you have chlorine, except fluorine, we will be applying for chlorine, bromine, and iodine, because we all know the AgF is not going to be obtained easily. It is having less polarization and all. So percentage of halogen is equal to atomic weight of halogen by molecular weight of silver halide into weight of silver halide formed divided by weight of organic compound into 100. So percentage of chlorine, weight of halogen is how much? Atomic weight of halogen, chlorine is 35.5. Molecular weight of silver halide, AgCl is 143.5 into weight of AgCl formed by weight of organic component to 100. Similarly, for bromine and iodine also you can write, what is the atomic weight of bromine?
80.
80 divided by what about Ag, Br? Ag is 108, silver is 108,
Yes, sir.
chlorine is
1
35.5, bromine is 80. What about iodine?
127.
127. Okay, you can just do the calculation. If you have chlorine, bromine, iodine, chlorine means 35.5 divided by 143.5. Bromine means 80 divided by 80 plus 108 is 188. Iodine means 127 divided by 127 plus 108 is how much? 235, right? You have the respective formula in this manner. So percentage of chlorine, percentage of bromine, percentage of iodine, you can figure out and use this formula to calculate the respective percentage of halogen in different types of organic compounds. Let us do one technique. Then same formula is going to be repeating for upcoming methods also, like for percentage of sulfur also we get the same. Percentage of phosphorus also we get the same. Do this method in do this problem in the Carrier's method of estimation of halogen. 0.5 gram of organic compound gave 0.12 gram of AgBr. Percentage of bromine. Percentage of bromine is atomic weight of bromine by molecular weight of AgBr 188 into weight of AgBr 0.12 divided by weight of organic compound 0.15 into 100. This is a 80 by 188 into 0.12 by 0.15 into 100. Try to solve it, you will get the answer. Okay. When you try to solve it, you will be getting 34.04%. You can check out the value and all. The Carrier's method is used for the estimation of halogens. Using this method, you can actually detect how much percentage of halogen is there, and estimation of sulfur, that is also used using Carrier's tube only. Same, the whatever the weight of organic compound you have, that is heated with the sodium peroxide, so that whatever the sulfur we have, that is going to be converted to respect to sulfate. If you remember, detection of phosphorus, how we have detected? Phosphorus we have converted to respect to phosphate ion or not? In the presence of heating Na2O2. This phosphate is converted to, in the presence of HNO3 is converted to H3PO4. H3PO4 is now converted to, in the presence of ammonium molybdate, NH4 taken twice, MoO4. You get a canary yellow, which is ammonium phosphomolybdate. Similar to that, you will be getting respect to sulfur also. Sulfur you convert to sulfate in the presence of oxidizing agent like a peroxide, like sodium peroxide. And that sulfate you treat with barium, you will get barium sulfate. Again, the formula is going to be same. Based on the barium sulfate formed, we will calculate the percentage of sulfur. Percentage of sulfur is equals to, how you will get? Sulfur converted to sulfate. Sulfate treated with the barium chloride to form barium sulfate. So percentage of sulfur is equals to atomic weight of sulfur, how much? Atomic weight of sulfur
32.
32 divided by molecular weight of, we have to take BaSO4 now, because in the halogens have been converted to respect to silver halides. So we have taken the molecular weight of silver halide. But here the sulfur has been converted to barium sulfate. So we have to take the molecular weight of barium sulfate. So percentage of sulfur is equals to atomic weight of sulfur 32 divided by molecular weight of BaSO4, how much? Try to do the calculation, you will be getting something around 233. Remember these values, 32 by 233 into weight of BaSO4 formed divided by weight of organic compound into 100. This is for the sulfur. Okay. Yeah, this is what I'm explaining. Estimation of sulfur. A weighed amount of organic compound is heated in Carrier's tube with sodium peroxide or fuming nitric acid. Sulfur converted to sulfate. Sulfur present in the organic compound is converted or oxidized to sulfuric acid. That means where you have sulfate ions, which is treated with BaCl2 to form barium sulfate. So it is filtered, the precipitate is washed, dried and weighed. If you weigh it, you will be getting the, you will be knowing the information regarding weight of BaSO4. So percentage of sulfur is equals to atomic weight of sulfur divided by molecular weight of BaSO4 into weight of barium sulfate formed divided by weight of organic compound into 100. So we can do this. This will be the formula. Percentage of sulfur is equals to 32 divided by 233 into weight of BaSO4 divided by weight of organic compound into 100. This formula you have to remember, students. We can't derive it in the exam. Derivation and all you can't do in the exam, right? So you have to remember the formula, but you have to know how that formula came. For the Geldas method itself, we have written the derivation. Like that, we can write the derivation for everything. In BaSO4, we have only one sulfur atom. So atomic weight of sulfur, BaSO total weight, and weight of BaSO4 formed by weight of organic compound into 100. That gives the percentage of sulfur, right? Try to figure out. In sulfur estimation, 0.157 gram of organic compound gave 0.4813 gram of barium sulfate. What is the percentage of sulfur? Percentage of sulfur is equals to 32 divided by 233 into weight of BaSO4, barium sulfate, how much? 0.4813 divided by weight of organic compound 0.15 7 into 100. Yes or no? So percentage of sulfur is equals to 32 divided by 233 into 0.4813 divided by 0.157 into 100. This will be giving the exact right answer to you to find out the percentage of sulfur found. Is that clear, students? Everything so far?
Yes.
Yes, sir.
And lastly, we have percentage of phosphorus calculation. There are two ways, like percentage of phosphorus. You can actually weigh from the magnesium phosphate, whatever the phosphorus you have, that can be converted to magnesium ammonium phosphate, and that magnesium ammonium phosphate can be converted to magnesium pyrophosphate. Like you can write the formula, magnesium pyrophosphate. Anyone know the formula? We'll look into the percentage of phosphorus calculation. Estimation of phosphorus, right? Here what we are going to do is, a weighed amount of organic compound is heated with a fuming nitric acid. Then phosphorus present in the compound is oxidized to phosphoric acid. That means phosphorus, whatever you have, that you are converting to H3PO4 in the presence of HNO3. This H3PO4 is treated with the phosphoric acid is precipitated as magnesium ammonium phosphate by addition of magnesia, that is a mixture of MgCl2, NH4OH and HCl. MgCl2, NH4OH and HCl. If you try to add, this H3PO4 will be converted to magnesium ammonium phosphate. What is the formula for magnesium ammonium phosphate? Mg will have how much charge? Mg will have +2. Ammonia, ammonium, NH4 +1. MgNH4 will have +3 in total. Phosphate PO4 will have -3. So total charge is neutralized. MgNH4 PO4 that will be formed. This is nothing but magnesium ammonium phosphate, NH4 MgPO4, and this will be converted to respect to Mg2 P2O7, which is nothing but magnesium pyrophosphate. Magnesium pyrophosphate. The magnesium ammonium phosphate is washed, dried, and is heated strongly to get magnesium pyrophosphate. That means what we have done ultimately, we have phosphorus in the organic compound. That phosphorus has been converted to respect to H3PO4 phosphate using oxidizing agents as well as HNO3. That H3PO4 is converted to MgNH4PO4 by treating with magnesia mixture, and that MgNH4PO4 is heated strongly to get a magnesium pyrophosphate. So in the magnesium pyrophosphate, how many phosphorus we have? Therefore, we can write the formula, percentage of phosphorus is equal to, what is the atomic weight of phosphorus?
31.
31. But how many phosphorus atoms are there in Mg2P2O7?
2.
2. So I can write total weight of phosphorus, total atomic weight of phosphorus in this is 62. What is the molecular weight of Mg2P2O7? Mg2P2O7, if you try to do, it will be something around 222. Fancy number, 222. 62 divided by 222 into weight of Mg2P2O7 divided by weight of Mg2P2O7 divided by weight of organic compound into 100. This is a formula. Everyone got this or not?
Yes, sir.
Yes.
Yes or no? This is one technique. What is this technique? In this technique, we have calculated the percentage of phosphorus, but we have also discussed different other way. What is the other way we have discussed, students, in the detection of phosphorus? Instead of treating H3PO4 with magnesia, getting magnesium ammonium phosphate and heating it strongly, getting magnesium pyrophosphate, what is the other way we have discussed? Phosphorus in the presence of Na2O2 converted to PO4 3 minus. This has been treated with HNO3 to form respect to H3PO4. This H3PO4 has been treated with ammonium molybdate. Yes or no? It is treated with ammonium molybdate to form canary yellow. What is that canary yellow? Ammonium phosphomolybdate. What is the formula of ammonium phosphomolybdate? NH4 taken thrice PO4 dot 12 MOO3. This is canary yellow. Yes or no? So now try to estimate the percentage of phosphorus from this. Using canary yellow PPT also we can estimate, right? So percentage of phosphorus is equals to in NH4 taken thrice PO4.12 MoO3. How many phosphorus atoms are there? Only one atom is there or
One.
not? So what is the
31
atomic weight?
by
31 divided by this total atomic weight. You have total molecular weight of this compound. You have to find out, which will be some
1877.
1877. Very good. Into weight of this, weight of ammonium phosphomolybdate, ammonium, or you can write the formula, weight of canary yellow PPT, that is NH4 taken thrice PO4 dot 12 MoO3 divided by weight of organic compound into 100. Okay, these are the two ways to actually estimate how much percentage of phosphorus is there in that particular organic compound. Is that clear or not?
Yes.
Sir.
Right. So whenever they have given this much amount of ammonium pyrophosphorus obtained, you have to use this formula. Whenever they have given this much weight of ammonium phosphomolybdate is obtained, you have to use the other formula, because in both the formula we have different amount of phosphorus, because the formulae are different. Yes or no? And lastly we have, yeah, these are the formula. H3PO4 converting into MgNH4 taken PO4. Percentage of phosphorus is equal to 62 by 222 into weight of Mg2P2O7 form divided by weight of organic compound into 100. The other way is using ammonium phosphomolybdate. Percentage of phosphorus is equals to 31 by 1877 into weight of ammonium phosphomolybdate divided by weight of organic compound into 100. The same formula which you have written earlier. The next one is last one, percentage of or estimation of oxygen. How to estimate oxygen? How to estimate oxygen? Yes, Karthik says Mg2P2O7 for the magnesium pyrophosphate. Very good. Estimation of oxygen you can do like generally in one way we can actually estimate the percentage of oxygen by subtracting percentage of all other elements from 100. Oxygen, percentage of oxygen is equals to 100 minus percentage of all other elements whatever they are present in the organic compound. But we can also have the formula as well. This is what I was saying. Usually percentage of oxygen in organic compound is determined by the method of difference, that is percentage of oxygen is equals to 100 minus sum of percentage of all other elements. Oxygen present in the organic compound is estimated by Aussie's method. A known amount of organic compound is subjected to pyrolysis in a stream of nitrogen. What happens whenever you try to heat the compound? Whatever the mixture, whatever you are getting, that will be containing oxygen or not, because the organic compound is heated, it will evolve. Oxygen is there, right? That oxygen is converted into O2 gas, and we will be getting other gaseous products also, because we are heating to very high temperature. That oxygen is actually treated with carbon to form respective CO, and that CO which is obtained, that is converted into CO2 by passing over iodine pentoxide. So based on this iodine, we will be estimating like how much percentage of oxygen is there. So what we are going to do generally, simple analysis, whatever the organic compound you have, that will heat. Whenever you try to heat the organic compound, you will generate O2 and other gaseous products. Yes or no? Organic compound upon heating generates O2 and other gaseous products. The carbon in the organic, like red hot coke. Now the whatever the organic compound you have heated, whatever the oxygen you're getting, that oxygen you pass through red hot coke. This is not from the, this carbon is not from the organic compound, this is from red hot coke. Through this oxygen is passed O2, you will generate what? Respective carbon monoxide. This carbon monoxide is converted to carbon dioxide CO2 whenever you try to pass this in the presence of iodine pentoxide I2O5. When you try to convert the CO into CO2, you will be using I2O5. CO formed, whatever the CO formed in the above step, first step, second step, third step. Organic compound heated to form oxygen. Oxygen passed over red hot coke to form respect to CO. That CO is converted to CO2 in the presence of I2O5, that is iodine pentoxide. Whatever the mixture of gases we have, so I2O5 treated with CO means we get CO2 and I2. The CO2 and I2, they were passed through Ki solution. They were passed through Ki solution. Ki will absorb what? Potassium iodide.
Carbon dioxide.
Ki, not KOH. Potassium iodide will absorb iodine. Okay, the resulting gases, that means CO2 and I2, they are passed through potassium iodide, which absorbs iodine. This Ki will absorb iodine.
Yes.
And whatever Ki will absorb iodine, and whatever the CO2 is left out, right? CO2 left out, that is passed through KOH. KOH will absorb CO2. So ultimately, you figure out the, from the weight of CO2, you are calculating the percentage of oxygen. So percentage of oxygen is equals to, in the CO2, from the CO2 you are calculating how much amount of oxygen is there. In the CO2, how much amount of oxygen is there, students? Percentage of oxygen, how to find out? Percentage of oxygen is equals to atomic weight of oxygen divided by molecular weight of CO2 into weight of organic compound, weight of CO2 formed by weight of organic compound into 100. That means you will be using the formula percentage of oxygen is equals to 16 divided by, here you are not supposed to write 32 as although we have two oxygens. Since we are talking about only one oxygen atom, percentage of oxygen is equals to 16 divided by 44 into weight of CO2 formed divided by weight of organic compound into 100. So these are the techniques. Is that clear or not? Three steps are there. Organic compound, you heat it to generate O2 gas. Whatever the O2 gas we have, that you convert to carbon monoxide by passing over red hot coke. Once you get the carbon monoxide, you treat that carbon monoxide with I2O5, iodine pentoxide, to form carbon dioxide and iodine gas. This mixture of carbon dioxide and iodine, you pass through Ki, potassium iodide. Ki will absorb iodine and left out CO2. Whatever the CO2 left out, that is absorbed by KOH. So based on the increase in the mass of KOH, we will find out what is the weight of CO2. So ultimately, we will be getting this percentage of oxygen is equals to 16 divided by 44 into weight of CO2 by weight of organic compound into 100. Everyone got this or not?
Yes.
Yes, sir.
Yes. The mixture of gaseous products containing oxygen is passed over red hot coke. Then all the oxygen is converted into carbon monoxide. 2C plus O2 is converting into CO. The CO formed is quantitatively converted into CO2 by passing over warm iodine pentoxide. The same equations we have written. CO plus I2O5 converts I2 plus CO2. The I2 plus CO2, the resulting gaseous mixture, is passed through potassium iodide Ka solution, which absorbs iodine, and then passed over KOH to absorb CO2. So percentage of oxygen is given by this formula, 16 by 44 into weight of CO2 formed divided by weight of organic compound into 100. Even we got the same formula in the previous slides as well. Weight of CO2 by weight of organic compound into 100 into 16 by 44. So these are the different formula to quantitatively estimate how much percentage of what type of element is present in the organic compound. Right, students? Is everything clear so far?
Yes, sir.
Yes, sir.
Okay. So these are the qualitative, quantitative techniques. So I know most of the students neglect this part. Okay. I have seen lot many students, right? I know students are neglecting this part of the organic chemistry, like quantitative and qualitative analysis and purification, but never do that. Because many times questions have been asked. It is quite important because it is a slightly tricky one to understand how to purify things, how to estimate a particular element, how to quantitatively estimate percentage of any element present. So never neglect any question from these topics. So let us start with the next topic named hydrocarbons. Hydrocarbons means what do we have?
Carbon, hydrogen.
Yes, obviously carbon and hydrogen. Along with that, I mean to ask, like,
Nitrogen, oxygen.
yeah. In hydrocarbons, we have carbon and hydrogen only. And in the organic compounds, we will be having different other elements like nitrogen, oxygen, sulfur, magnesium, and all other halogens and all. But hydrocarbons means I am trying to say that we will be having three main groups like alkanes, alkenes, alkynes, and benzene. Okay. So mainly our focus of study will be regarding the properties of those particular compounds: alkanes, alkenes, alkynes, and benzene. So hydrocarbons, alkanes, alkenes, alkynes, and aromatic hydrocarbon like benzene. And we will be looking at, we have studied nomenclature, isomerism for all types of compounds. So whatever with the organic compound you have, you should be in a position to name it, or you should be in a position to also express what are the different types of isomerism possible for that organic compound, and how many number of isomers are possible. All that questions you should be knowing. So hydrocarbons will be classified into like compounds of carbon and hydrogen alone, and we have alkane, alkene, alkyne, and aromatic hydrocarbon. So we'll study one by one now. Alkanes. So study will always go with three perspectives: methods of preparation, physical properties, and chemical properties. How we have prepared, how can we prepare that particular organic compound, like it may be alkane or alkene or alkane, whatever it is. What are the different physical properties? Like physical properties mainly discuss about boiling point and solubility. Chemical properties means different chemical reactions shown by that organic compound. Okay, so let us start with that. Methods of preparation, physical properties, chemical properties. Preparation method is, first method is reduction. So there are, you can reduce. First, what type of reduction you can take into account? From alkene, can I do reduction, reaction of haloalkanes with sodium, from carboxylic acids, from Grignard reagents, from metal carbides by hydrolysis. In the reduction, what you can think of, students? In the reduction, what reactions will come to your mind?
Hydrogenation.
Hydrogenation. Woods reaction is second one, right? Reaction of haloalkane with Na. Reaction of haloalkanes with Na is Woods reaction. What is the mechanism of Woods reaction?
Free radical mechanism.
Free radical path. Very good. From carboxylic acid means what type of reaction you can think of? Two things will come to your mind generally: decarboxylation and Kolb's electrolysis. In decarboxylation, what happens? What is the intermediate in decarboxylation? I'm just asking. We have not discussed that. Just asking whether you remembered or not. Decarboxylation, what happens? What is the intermediate? Carbanion ion. Okay. Kolb's electrolysis. We can do electrolysis. Generate at anode, at cathode will be 18 different types of products. Grignard reagents. Grignard reagents. It can act as base to pick up acidic proton. Okay. R minus can act as base and picks up acidic proton, and acidic protons are those protons which are connected to more electronegative atoms like nitrogen, oxygen, fluorine, sulfur, chlorine, and to sometimes in some cases hydrogen connected to carbon is also acidic proton, in which case sp hybridized carbon, as well as if you try to remove the proton and if the resulting compound is aromatic in nature. I have given one example. This carbon. Here we have two hydrogens. It is not sp hybridized, but still that hydrogen is picked up to form your respective compound in this way, which is aromatic in nature, and from metal carbides by hydrolysis. So these are the different ways which we can look out broadly, like in the reduction, what we happen, hydrogenation, think of metal reduction, also we can think of Wood's reaction, free radical path, carboxylic acid decarboxylation, carbanion is formed, Kolb's electrolysis, anode and cathode, anode and cathode, we have different sets of products. pH is also going to be changed at cathode. How is it changed and how it is not changed? Grignard reagent, if it acts as a base, it picks up the proton. When it will act as a base, when we have acidic proton, yes or no? When we have acidic proton, which protons are acidic? If hydrogen connected to more electronegative elements, those are acidic protons. Metal carbides, they can also undergo hydrolysis to form respective alkenes. This is a overall broad view. Let us start with one by one. Reduction, addition of hydrogen or removal of oxygen, nitrogen, halogen. So reduction, you can take reduction of unsaturated hydrocarbon, reduction of hydrocarbon derivatives. Two types of reductions you can think of in the preparation of alkanes. Reduction of unsaturated hydrocarbon, reduction of hydrocarbon derivatives. Reduction of unsaturated hydrocarbon, in this perspective, what you can think of? Reduction of unsaturated hydrocarbon means you can think of alkenes and alkynes. Alkenes and alkynes, how they will undergo reduction? What was the mechanistic approach? I have discussed this many times. I have taken alkene, trying to add H2 in the presence of palladium. We get alkane. What is the mechanistic approach?
Through electromagnetic effect.
Electromagnetic effect, Faizan?
So adsorption H2 on the surface of palladium.
Yeah,
After that,
very good. Adsorption of both alkene and H2, they are going to be adsorbed. After they adsorb, they will be getting the reaction happening. After they react, they will form respective alkanes. That is, hydrogen is simply added. Okay, and reduction of hydrocarbon derivatives like COOH, OH, CHO, X, C double bond O. Can anyone remember how the C double bond O group can be directly converted to CH2? Any reactions you remembered? C double bond O has to directly convert to CH2 group. C double bond O group has to directly convert to CH2 means we have two reactions: Wolff-Kishner reduction, Clemenson's reduction. We'll discuss all those. Okay. So reduction, using reduction, you can actually form respective alkanes. First one is reduction of unsaturated hydrocarbons. Here adsorption will happen. Adsorption will happen. Reduction of hydrocarbon derivatives, COOH, OH, CHO, X, and C double bond O. So from alkenes and alkynes reduction, when alkenes and alkynes are completely hydrogenated in the presence of metal catalyst, alkane is formed and addition of hydrogen is syn. Syn means same side. Whatever the hydrogen you are going to add, they are going to be added on the same side. Like C triple bond C, when you treat with H2 in the presence of catalyst, you get a C double bond C and two hydrogens connected to carbon on the same side. C double bond C, again H2 in the presence of catalyst, it forms CH2, CH2, single bond carbon, carbon. The hydrogens are again added on the same side, syn addition. Catalyst, we use palladium or platinum at ordinary temperature and pressure. Nickel 200 to 300 degrees Celsius, Sabatier Sundance reaction. Raney nickel means fine grains of nickel aluminum at room temperature. Raney nickel will have more surface area, more will be the adsorption. Is that clear to everyone or not? We have taken the unsaturated hydrocarbon, treated with the H2 in the presence of different catalysts like palladium or platinum, or Sabatier Sundance reaction like nickel at high temperature, or Raney nickel. You will generate respective alkane. Alkyne or alkene converted to respective alkane. And if you think of one more term, along with the catalyst, we will be having some promoters, poisons. Anyone remember those terms?
Sir,
Anyone
quinol.
heard of? Yeah, anyone heard of promoter or not?
Yes, sir.
Yes, sir.
Can you repeat the question again?
The question is, we are saying a catalyst is there, palladium or platinum. Along with the catalyst, we will be having some promoters. What are promoters? Every catalyst will have some catalytic activity. Yes or no?
Yes, sir.
Every catalyst will have some catalytic activity. Promoter is that species which can increase the activity of the catalyst or decrease the activity of the catalyst.
Increase.
Increases.
Yeah, which increases the activity of catalyst is nothing but promoter. How does it increase? Anyone know it or not? Suman, how does it increase?
I don't know, sir, how does it work?
Don't know. So we have general catalyst like this. Like if I am saying about any catalyst like palladium or platinum, at a different lattice sites, we have elements like palladium is present or not. What was the mechanistic approach is, if you consider any metal, on the surface you will be having different crystal lattice sites. At different crystal lattice sites, you have respective metal atoms or metal ions, metal kernels we say. Now, for this palladium or platinum, if we add a promoter role is actually to increase the activity of the catalyst. What is our reaction? We have alkene, that means R dash connected with carbon, R dash CH double bond CH2. These were attached to respective metal, and we have also attached hydrogen. 2 hydrogen atoms were also attached. Yes or no? Like you can imagine this mobile phone here we have. This is a metal surface, right? Yes or no? You can see this as metal surface or not? This is one metal surface. Obviously, mobiles are made of metals, right? This is a metal surface. On the metal surface, we have adsorption happening. Let us say this is alkene molecule. This alkene got stitched to this metal surface. And we have one more molecule that is also stitched to the metal surface, like H2. Alkene plus H2 we are adding. H2 and alkene, after they stitch to the metal surface, they react. They react, the pi electron density of alkene will be lost, and the new electron density or the new bonds are going to be formed, generating R dash CHH single bond CH2H. This is nothing but your alkene. Understood this point or not? All of you. R dash CH double bond CH2. This is adsorbed on the metal surface. H2 gas adsorbed on the metal surface. After the alkene and H2 gas adsorbed on the metal surface, they start the reaction to form respective alkanes. This is what happening in this particular adsorption of or conversion of respective alkene or alkane to particular alkenes. But there are some reactions where this just adsorption of reactants will not be sufficient for them to react. If here we are saying they got adsorbed, so they are going to be reacting. But even though there are some reactions where even though adsorption occurred, they are not going to react directly. That means the bonds which are present, right, those bonds are going to be very strong. Let us say if we have nitrogen, N2 plus 3H2 gives rise to 2NH3. This is a reaction or not? In
Yes,
N2
sir.
molecule, we have a triple bond between 2 nitrogen atoms. In H2, we have a single bond between 2 hydrogen atoms. In ammonia, we have 3 single bonds, 3 NH bonds are there. Can I say N2 gas adsorbed? In the Haber's process, you can see a promoter or not? Yes or no?
Yes, sir.
Yes, sir.
What is the promoter in Haber's process?
Molybdenum.
So how is that going to act as promoter? Like we can say N2 gas stick to that particular N triple bond N is there, which was adsorbed. Hydrogen single bond, that is also adsorbed. But N triple bond N is a very strong bond. That bond cannot be cleaved even though it got adsorbed to that particular metal. So I have to weaken the bond between 2 nitrogen atoms. Between 2 nitrogen atoms, whatever triple bond is there, that bond has a very high bond dissociation energy that is not going to be cleaved easily. So I have to cleave that bond. How can I do it? So you are saying molybdenum and all. So what is the role of this molybdenum? How it increases the activity? So there are two ways. molybdenum will occupy the interstitial sites. Imagine the case if molybdenum occupying the interstitial sites. Here we have, these are the lattice sites. Yes or no? Understand this point carefully, students. In the initial scenario, we have lattice, crystal lattice sites like this. N triple bond N has been adsorbed in this fashion. Can I say this is the interstitial site? In that interstitial site, if molybdenum is present, can I say now we have the scenario somewhat like this or not? This is the promoter atom. So now adsorption has to happen. This is the crystal lattice site. Here we have nitrogen atom. This is the crystal lattice site. Here also we have nitrogen atom, and we have N triple bond N as it is. Look at the both the cases. Whenever the interstitial site is occupied by molybdenum, what I can say is the interspatial distance or the interlattice distance that has been increased. Because of that, the bond energy has been decreased or not?
Yes, sir.
Yes or no? So if the promoter atom occupies some of the interstitial sites, what happened is, like if there is a bench and two students sit in that particular bench, they are very good friends. And if third person come and sit in between them, and he is always disturbing both of them, and he is making new friendship, the old friendship has to be disturbed. Same thing happened. This is the third person. This molybdenum atom which is acting as a promoter, or any other atom which is acting as a promoter, if that is increasing the interlattice spacing, if it is increased, the bond energy will be decreased. The N triple bond N now will be having greater bond length, which has to be decreased. If it decrease, the reaction will occur. N2 plus H2, and H2 is also adsorbed, right? Now the reaction between nitrogen and hydrogen will start, and NH3 is going to be formed. That is why promoters are those species which are going to increase the activity of the catalyst, right?
Yes, sir.
Here such promoters are not required. We can just use the catalyst and do the reaction, maintaining high temperatures. And this is how the reaction can be done. We have taken alkene. You can just look at the lattice. Very high number of atoms are there. Although we are writing some 3 atoms, 4 atoms, you can just imagine very high number of atoms will be there, right? And that is how the adsorption happened with the alkene, and that is how the adsorption of H2 happened. Adsorption, what is the main role of adsorption or reason of adsorption? Because of the unbalanced forces, and after adsorption the pi electron density is lost, and we form a new bonds with the carbon hydrogen. So because of that new bonds, the pi bond has been converted to respective sigma bond. That means pi electron density is lost, and we get new CH bonds. Ultimately, the two hydrogen atoms which are going to be added, they are adding from the same side for the adsorption to be effective. That is why we can say syn addition occurs. That is why we can say syn addition occurs. Right? That is the first reaction. CH2 double bond CH2 plus H2 in the presence of nickel, palladium, platinum, you get ethane. CH3 CH double bond CH2 plus H2 nickel, palladium, platinum, you get wherever double bond we have, that you have to convert into single bond. CH3 CH2 CH3 propane. CH3 C triple bond CH plus 2H2 in the presence of nickel or palladium or platinum, you will get CH3 CH2 CH3, which is again called as propane. It's again called as propene, propine, or ethene. They will be converted to respective alkanes whenever you heat them with nickel or palladium or platinum. Is that clear, students?
Yes, sir.
Yes, sir.
Right? Writing the reaction in this manner is very simple. Like how the thing is happening, we have to understand based on adsorption and all. Next type of reduction is by reduction with red phosphorus and HI. So HI removes all oxygen and adds hydrogen. So if you look at C double bond OH, it will be converted to C double bond OH, and then C double bond OH converted to carbonyl, carbonyl converted to respect to alcohol, and alcohol converted to respect to alkane. Removes all the oxygens and tries to add hydrogens. R C double bond OH, red phosphorus in the presence of HI, forms what? R C double bond OH will form first R CH OH CH, again it forms R CH2H, which is nothing but RCH3. R C double bond OH treated with red phosphorus in the presence of HI forms RCH3, and I2 is released. Along with that, H2 is evolved. RC double bond or red phosphorus, it will form what? RC double bond or first you try to add a hydrogen to C double bond, so you'll get RCHOH. Again you try to add hydrogen, you'll get a RCH2 OH. If it is hydrogen is added to OH, it becomes H2O. H2O is lost. RCH2R plus H2O is lost. ROH red phosphorus, you will get a hydrogen. You are going to add this to this R group and oxygen. You get RH and H2O is lost. RC double bond OH means again you will get RC double bond OH or CHOHH or CH2H plus H2O. That means RCH3 is obtained. If you take respective carboxylic acids and try to add HI in the presence of red phosphorus, you will get respective carbonyl, carboxylic acid to carbonyl, carbonyl to alcohol, alcohol to respective alkane. Everyone got this or not? This is nothing but reduction by reduction with the red phosphorus and HI at very high temperature, like 150 degrees Celsius. High temperature you can say. And in these reactions, red phosphorus you are going to use to remove whatever the iodine is going to be formed. Okay, red phosphorus is going to be used to remove iodine. By reduction of aldehyde or ketone. Suman will discuss whenever it comes to a correct approach. Okay, there was no restriction so far. We can convert acids, carbonyls, alcohols to respective alkanes. You treat with HI in the presence of red phosphorus. By reduction of aldehyde or ketone, they will be converted to respective alkane by using Clemenson's reduction as well as Wolff-Kishner reduction. Clemenson's reduction means what are the reagents used? Zinc amalgam in the presence of concentrated HCl. That means here we are using acidic medium. Function is aldehyde or ketone is going to be converted to alkane. RC double bond of CH3 in the presence of zinc amalgam and concentrated HCl at high temperature forms CH3, CH2, CH3. In this reaction, the C double bond is converted to CH2 group like methylene group. Mechanism is not required, students. In the mechanistic approach, you can observe zinc will be converting into respect to Zn plus 2 and 2 electrons. These 2 electrons will also act as nucleophiles and they also attack the electrophilic carbon. Okay. In the mechanistic approach, oxidation of zinc occurs. Oxidation of zinc occurs and electrons lost will act as nucleophiles and attack electrophilic carbon. Attack the electrophilic carbon. Right? Wolff-Kishner reduction means reagent will be NH2, NH2. That means NH2 in the presence of OH minus upon heating, and we also have ethylene glycol. Function is again aldehyde or ketone will be respectively converted to respective alkane. CH3 C double bond of CH3 treated with NH2 in the presence of OH minus upon heating forms respective CH3 CH2 CH3 plus N2 gas is evolved. In this reaction also C double bond group is directly converted to CH2 group. In this reaction also the C double bond will be directly converted to respect to CH2 group. Example, try to solve this example. We have this particular compound given to you. In which of the following reagent can be used for this conversion? Zinc amalgam in the presence of concentrated HCl, NH2 in the presence of OH minus, red phosphorus plus HI in the presence of heating, or all of this. Try to solve, all of you, try to solve this particular question and give the answer. Which we have to use the C double bond has been converted to, the C double bond has been converted to respect to CH2. Yes or no? C double bond has been converted to respect to CH2. Then which was actually used? Either you are doing Clemenson's reduction or you have to do Wolff-Kishner reduction. And why we have to do that particular reduction, with the reasons we have to explain. No one? So can I say all of these or not? Because zinc amalgam in the presence of HCl, we have only C double bond group, right? We do not have any acid sensitive groups or base sensitive groups. If I have a group like OH, this OH can be reacting with the HCl because H plus ions will be attacking the lone pair of electrons and oxygen attack the H plus. So it form OH2 plus. This OH2 plus will be lost. Then chloride ion will attack this particular carbon. If I have any acid sensitive group, then I am not supposed to use. If acid sensitive group is there, group is present, then zinc amalgam in the presence of HCl should not be used. Should not be used. If a base sensitive group is present, then N2H4 in the presence of OH minus upon heating should not be used because base is going to be affected. But here there are no such groups, so I can use either Clemenson's reduction or Wolff-Kishner reduction and red phosphorus in the presence of HI. So all of these can be used. If I place OH here and OH here also, if I place OH here and OH here also, then I am not supposed to take option 1 into account because OH is not affected, right? OH is going to be affected when I use constant HCl. So that is not affected means I am not supposed to use respective zinc amalgam in the presence of HCl. Okay. Then next method is a reduction method. After Clemenson's reduction, Wolff-Kishner reduction, reduction of unsaturated hydrocarbons and red phosphorus in the presence of HI. We can use reduction of halides. RX can be converted to respect to RH by using reducing agents. Reducing agents may be Zn plus HCl, tin plus HCl, Fe plus HCl, zinc plus acetic acid, metal plus acid. Metal plus acid is converting the respective RX bond to respect to RH bond. That means removal of halogen has been done. Reduction of halide to respect to alkanes. This is done in the presence of metal plus acid. Example, if you take CH3, CH2Cl treated with the Zn in the presence of HCl, it will form what? The chlorine is going to be lost. You will get CH3. That means respective ethyl chloride. Ethyl chloride is converted to respective ethane. Ethyl chloride is converted to respective ethane. CH3, CH2, CH2Cl treated with the ZnHCl converts to CH3, CH2, CH3. Propyl chloride converted to respective propane. So metal plus acid will reduce the respective alkyl halide to respective alkanes. Is that clear, students?
Yes, sir.
Can anyone list out what are the 4 methods of reduction to form alkanes? Just method names. Yes. Right or wrong, you can just say out no.
Clemenson's reaction, Wolff-Kishner reaction.
Yes, very good. And then unsaturated hydrocarbons. Then you have metal plus acid converting the respective haloalkanes to respective alkanes, and then you will be having red phosphorus and HI. Fine, these are all the reduction to convert respective to form respective alkane, students. Then you will be having the reaction of haloalkanes with sodium. Reaction of haloalkanes with sodium is nothing but Wood's reaction. Haloalkanes treated with the sodium in the presence of dry ether forms RR plus NaX. Alkyl halide, whatever the haloalkane you have taken RX treated with sodium in the presence of dry ether, it will form respective RR and NaCl is going to be eliminated out. Dry ether will be acting as respective solvent in this particular reaction. Mechanism is free radical path. So Rx is going to be converted into R dot plus X dot. Mechanism is Na will be converting into Na plus plus electron. Rx will convert to what? Rx will convert it to R dot plus X dot. X dot will take up the electron which is obtained from Na. Na is converting into Na plus plus electron, right? So X dot, like halogen atom, like with one odd electron, will be taking up the electron to form halide ion. That Na plus will react with X minus to form NaX. And R dot will can react with another molecule, another free radical. They will combine with each other to form RR. This was the mechanistic approach. Okay, Na is converting into respect to Na plus plus electron. Rx will be treated with electron to form R dot and X dots. RR will be fusing together to form product. Like R dot will be fused together to form the product RR. Like symmetrical alkanes are formed. Like Wood's reaction, whatever you're using, that is used for the preparation of symmetrical alkanes, not for unsymmetrical alkanes. Even if we have unsymmetrical alkanes, what we have to take? We have to take two different types of alkyl halides. If you take two different types of alkyl halides, you will be always getting mixture of products. You are not going to get symmetrical alkanes. R dot plus R dot will be forming respective RR, which is nothing but your symmetrical alkane. Na plus X minus will form NaX. This is the mechanism approach. This is the mechanism of your particular Wood's reaction. Let us understand the same Wood's reaction with an example. CH3Cl will form what, students? CH3Cl treated with Na in the presence of dry ether.
CH3,
CH3, very good. How it is going to be formed? We have CH3 dot and CH3 dot will form CH3, CH3.
radical
Yes, right. Here we will get what? CH3, CH, CH3Cl treated with Na in the presence of dry ether.
CH3, CH. In place of
C-
Cl, CH3.
In place of Cl, we have CH3. That's it.
2,3-dimethyl butane.
2,3-dimethyl butane. Very good. Because these are the radicals obtained, right? If this carbon chlorine bond cleaves, you get a free radical here. That means CH3, CH dot CH3. Another such free radical is going to be fused together to form respective CH3, CH, CH3, CH, CH3, CH3. Okay. So symmetrical alkanes are going to be formed as a major product. If you want to prepare an unsymmetrical alkane, you have to take two different types of alkyl halides, where you will be ending up with mixture of products in that case. You form this third example, what you are going to get? Third example we have taken here, what is going to be the major product in this particular case? So this is a free radical obtained, yes or no? Cyclobutyl free radical. So those cyclobutyl free radicals are going to be combined with each other to form two cyclobutane rings combined.
Symmetry.
Note, reactivity of alkyl halides. You can see in the reaction, the carbon halogen bond is going to be cleaved or not. So which carbon halogen bond can be cleaved easily? The Ci bond, because iodine is very large in size, carbon is small in size. The carbon iodine bond can be cleaved easily. So Ri will be having the greatest reactivity, then RBr, then RCl, then RF. Ri greater, then RBr, then RCl, and then RF. We can form only symmetrical alkanes having even number of carbon atoms. If you talk of any unsymmetrical alkanes, you have to take mixture of alkyl halides. That's what I have told you. So symmetrical alkane, even number of carbon atoms. CH3, CH2, CH2, CH3. You can form from two ethyl radicals. CH3, CH2, CH3. How to prepare this? CH3, CH2, CH3. How to prepare this? If I have to prepare this, I have to generate CH3 dot and CH2 CH3 dot. CH3 CH2 dot. So this has to be obtained if I take CH3X. This will be obtained if I take CH3 CH2X. That means two different alkyl halides have been taken or not?
Yes.
Two
Yes.
different alkyl halides have been taken. So if I take two different alkyl halides, I'll be getting mixture of products. Because if I take this alkyl halide, I can also have a possibility of generating CH3 CH3. I can also have a possibility of generating CH3 CH2 CH2 CH3. I can also have a possibility of generating CH3 CH2 CH3. These three compounds can also be formed whenever I take two different types of alkyl halides. Unsymmetrical odd number of carbon atoms CH3 CH CH3 CH3. Again, it is symmetrical or unsymmetrical? Unsymmetrical.
Unsymmetrical.
Even number of carbon atoms. To produce this, I have to take CH3 dot and CH dot CH3 CH3. So the CH3 dot is obtained from CH3X, CH3X, and this will be obtained from CH3 CHX CH3. So again, I am taking mixture of alkyl halides. In that case, I will be getting mixture of products. That is nothing but a mixed Woods reaction. Whenever you take two different alkyl halides, you will be having mixed Woods reaction where you will be getting mixture of products. Mixed Woods reaction means CH3Br, CH3, CH2Br. Like I have taken two different alkyl halides treated with sodium in the presence of dry ether. You can generate what here? What are the mixture of products you can generate? Methyl radical can combine to form ethane. Ethyl radical can combine to form butane. Methyl radical and ethyl radical can combine to form propane. If two different alkyl halides are taken, then you will call that reaction as mixed Woods reaction. Yes, if two different alkyl halides are used, then it is known as mixed Woods reaction. And in Woods reaction, which alkane cannot be prepared? Can I prepare methane?
Then
No, sir.
Methane cannot be prepared because the two alkyl radicals has to combine. So methane has only one carbon. So methane is never going to be prepared. And what was the note you can understand is Woods reaction is not suitable for the preparation of unsymmetrical alkanes, because in the preparation of unsymmetrical alkane mixture, in the preparation of unsymmetrical alkane, mixture of products is obtained which cannot be easily separated. I am getting mixture of alkanes, then I have to use what type of method, students, to separate mixture of hydrocarbons? Fractional distillation, can I say?
Yes.
Sir.
We have applied fractional distillation, right, earlier? Fractional distillation, like crude oil, different fractions. Crude oil contains mixture of hydrocarbons. We have separated them into different fractions. Which of the following alkane cannot be prepared in good yield using Woods reaction? Try to answer this question.
third option.
Third option.
Option 3.
Yes or no? So which alkane is unsymmetrical? That will be right option. This is symmetrical, two ethyl radicals. This is also symmetrical. This is also symmetrical. So only option which is unsymmetrical is option 3. That means this is unsymmetrical alkane, so it cannot be prepared in good yield by Woods reaction. Very good. Try to do it. You will be getting what? So you will get this type of compound. The carbon bromine bond is lost, you get a free radical here. Carbon bromine bond lost, you get a free radical here. Those two free radical carbon atoms, they will combine now to form a compound like this. They are going to be fused. They are going to be fused and you will be generating a compound in this fashion. Try to do it here. So compound given carbon chlorine bonds, sodium in the presence of Pd2O, dry ether, you have to do Woods reaction. So what you can think of is, first thing you have double bond here, carbon chlorine bond cleaved, you generate a free radical, and what I can think of is, I can just connect the two free radical carbon atoms and form this type of ring. Is this going to be major product? It will be minor, it is not the product. Why? Earlier you have written the same product, sir, but not why? But not here, why?
Sir,
Because earlier we have the free radicals. which are not in resonance with any systems. But here we have adjacent double bond which is in resonance or not. So I can think of this particular double bond is giving one electron to this particular carbon atom, one more electron to this carbon atom. So it will give what? Double bond here. This one electron on this particular carbon and the other electron on this carbon will form a double bond here. We have one electron here and one electron here. Because double bond we can imagine as one electron to each carbon atom, right? So now we can write down this as benzene. Benzene has aromatic nature which is aromatic stabilized. So that is why it is going to be more stable. So we'll get what? If you try to write the resonating structure of pi electron density into like pi free radical resonance, you will get respect to compound in this manner, which will fuse now to form benzene. Clear or not, everyone?
Yes, sir.
Yes.
Yes, right. So now try to write down the major product here. So I can just cleave the carbon chlorine bond, generate a free radical. So I'll be having double bond here, free radical here and free radical here. Let us give numbering 1, 2, 3, 4. So that I am now going to write the 2, 3 pi electron density and this free radical on first atom into resonance. So 1 electron to this particular second, 1 electron to third. So I can write 1 electron on second and 1 electron on first. They will form a double bond. 1 electron on third as it is present. 1 electron on fourth as it is present. Again, it is nothing but 1, 2, 3, 4. Is there any difference between these two structures?
No, sir.
There is no difference, right? Even though you try to write the resonating structure, there is no difference. So can I directly combine these two now? One more such radical.
No, sir.
So I have, why?
Because it will generate anti-aromatic structure.
Oh, very good. It will generate anti-aromatic. So what happens now? It is going to be anti-aromatic compound. Anti-aromatic compounds are highly unstable. So what happens now? Anti-aromatic compounds will undergo dimerization. If you remember, I have explained this point with the same example. The dimer is now going to be formed. Okay. So you'll get this type of product as a major product. Okay. Anti-aromatic compounds undergo dimerization. They will not be formed directly. Here we get this type of compound which is not anti-aromatic. It is non-aromatic. It is non-aromatic. Okay, it is not aromatic. It is not anti-aromatic. It is non-aromatic. So such type of compounds are going to be formed, which are going to be the major products in this particular reaction. Right, non-aromatic compound is obtained. CH3, CH2Cl plus CH3, CH2, CH2Cl in the presence of sodium in the presence of dry ether, which is not obtained. Try to answer this question. Which is not obtained? Like 2 ethyl radicals can combine to form N-butane, that is possible. 2 propyl can combine to form N-hexane, that is also possible. Ethyl and propyl can combine to form N-pentane, that is also possible. But isobutane, is that possible?
No, sir.
Isobutane is not possible, so that is not obtained. And then comes Fittig reaction and Woods-Fittig reaction. What is Fittig reaction, students? Fittig reaction means instead of alkyl halides, if you take haloarenes, like aryl halide, if you take aryl halide treated with sodium in the presence of dry ether, will now form like biphenyl systems. Like the carbon chlorine bond here is going to be cleaved, although this reaction is not going to be so easy as that of alkyl halides, because there you are getting simple free radicals, but here you are getting a phenyl radical which is unstable. Phenyl radical is slightly unstable due to electronic repulsions. Woods reaction means you have to take RX, RX. Fittig reaction means you have to take aryl halide. Woods Fittig reaction means you have to take one alkyl halide and one aryl halide. You will be getting mixture of products. Out of that mixture, which is major? Out of that mixture, you can say this is going to be major, because this alkyl radical and aryl radical, they are going to be formed. They are going to be reacting first, and the side products are also obtained, like mixture is going to be obtained. Right, students, these are the 2 methods of preparations of alkanes from reductions, unsaturated compounds, Clemenson's reduction, red phosphorus HI, and also we have treated with a metal plus acid treated with alkyl halides. After that, we are looking at Woods reaction and different other cases. Next class, we will continue with the different other methods like carboxylic acids and all. After that, we will go with the physical properties, chemical properties, and all other studies. Fine. Thank you all. Bye.
Thank you, sir.
Thank you, sir.
Thank you.